In part 1 of lecture 10, we will discuss file basics. The concept of a file is similar to the way in which we think of it in the real world. It is a collection of data that we need to keep stored somewhere safe, somewhere where we can find it quickly when we need it. This is the original definition of a file as a computer system views it. This view has evolved over the years, and many computer systems view any flow of data into or out of the computer through any of its input or output devices, as well as its external storage devices. This view of a file includes the earlier view and is the concept of a file used in most modern operating system designs. Like anything else in a computer system, a file has attributes or properties. Exactly what these properties are may vary from system to system, but generally there are a few things that are always included because they are either necessary for the operations of the system or because they make it easier for people to use the computer. Most files have names because people want to have a means of identification for the file that they can relate to easily. These are usually character strings and are used in searching for the file. However, once the file is opened, the system itself will not use the name. As we shall see shortly, many files have some underlying structure that is understood by either the operating system or by the applications that use them. Some systems provide support for different types, freeing the application programmer from some of the work associated with using these files. Other systems provide no support for different file types, leaving the matter entirely to application programmers. Having a file does us little good if we can't find it. This requires that the system be able to keep track of where the file is located. By this we mean on which device is the file located, and if it is a secondary storage device, where it is located on that device. We may need to know the size of the file, and this can be expressed in one of several different ways. Most multi-user systems will provide some means of protecting files, restricting who can use what, and restricting who can write in a given file or in a given directory. Given the operating system's role in allocating resources, and given the manner in which it manages memory, we should expect this. There is other administrative information that we may need, such as who owns the file, when it was created or last modified or last accessed. This is important for the security or efficient operation of the system. File operations fit into several categories. Let's take a look at a few of the activities that define the basic state of a file. Existing files must be opened before they are used and closed afterwards. Even programs that do not explicitly open files will do this and close them at the end. We will talk more about this later. The life cycle of a file includes its birth and death. This means that we need a mechanism for creating them when we need to and deleting them when we are finished. This includes temporary files used by the operating system and application programs of whose existence the user may not even be aware. Lastly, to make life easier for the end user, we want a mechanism for copying, renaming, and listing files. A file cannot be used without opening it. Opening it usually means initializing the data structures used by the operating system to find the file, keeping track of what is being read, and of other important system data. Without such a structure, it is impossible for the operating system to access the file and maintain any sense of control. When the program terminates, and frequently before that, this process must be reversed, so there is room to store data about other files that this user or other users wish to use. There are two reasons for this. There is a finite amount of space available for such data in memory, and we want to be careful if we are going to allow a second user to open a file. Creating a file will begin with creating a directory entry and allocating some space for it. Destroying a file means making both of these available for reuse. We will discuss this in greater detail later. Of these operations, only renaming a file really is an operation in itself. Copying a file can be done by creating a new file, reading the old file, and writing its contents into the new one. Listing a file can be done by reading the old file and using either the screen or the printer as an output device for its contents. But most operating systems include utilities for these tasks because they are so common. There are two basic operations on individual data items: reading and writing. Reading means moving data from the file, and writing means moving data to the file. Updating is a little different in many cases from writing, because it means changing the data that is already stored in the file. Writing usually implies that new data is being added to the file. The distinction becomes more important in database applications, where updating data on a current employee would be viewed differently from adding data to the file about a newly hired employee. As I said earlier, an operating system needs ready access to certain basic information about the files it needs to access. That is precisely what opening a file is all about. While this may include other information as well, it must include the file pointer, which tells the system where it will perform the next read or write operation. If we are reading a byte at a time, or reading some larger accumulation of data, the pointer will indicate what this next byte or more is, or exactly where we can find it. We will need to know exactly how many processes have opened this file. What is particularly important is that the first file to open will cause the operating system to create the necessary structure for the open file. But if other processes can access this file, for reading only, for example, it will be the last file using it that is responsible for closing it. If the file that opened it has to do this as well, it may get in the way of other files making use of it at that time. Lastly, the system needs to know where the file is on the disk, if it is in fact a disk file. In any case, it must know on what device the file is located. Different types of data require different file formats. Unix itself provides no support for different file structures or types. DOS and Windows are a bit different. There is a minimal amount of support for certain file types by the operating system itself. .exe and .com files are executable files. .bat files contain a series of commands that are accessed by the file's name. And .sys files contain drivers for various devices within the computer system. However, there are a large variety of other file types that are not supported by the operating system itself, but by various programs that the user uses, such as object files, source code files, picture files, sound files, and so on. For example, different word processing programs will use different extensions to distinguish between their own files and files created by other word processors. That's why Word uses the extension DOCX, and Excel files use the extension XLSX. Both programs can read their own format. Windows does not support these directly. They are listed in the registry along with the applications that open them. These applications are responsible for these various file types.